Hello, in this video I'm going to talk about the inverse function. So we have to identify whether a function has an inverse or not, right? So there are functions which does not have inverse function. So there are two approaches to determine whether the function is has an inverse. There's algebraic approach and graphical approach. Graphical approach means you're drawing the graph and you see the graph. Okay, you see the graph, and by doing some tests, you know that this is not a does not have an inverse. So algebraic approach is you apply algebra. Okay, you're using algebra without the graph. Okay, to explain algebraically about whether the function has an inverse or not. So I'm putting a 3 star here is to tell you that if you want to show something, if you want to show that whether a function has an inverse or not, the most important thing is you must show that the function is a one-to-one function. So it means very easy. In order to show something is a one-to-one a function has a inverse, we're using the one-to-one. All right, we determine whether the function are one-to-one or not. If not one-to-one, means that there are if the function is not one-to-one, means that the inverse of the function does not exist for the function. All right, so okay, let's see. So now we start with the algebraic test. Algebraic test. Okay, algebraic test. Algebraic test, very simple. We have this test, fx1 equals to fx2. So this is what we mean by algebraic test. Algebraic test is we assume that fx1 to be fx2, means that x1 and x2 to be we assume that x1, x2 is a different value of x. Okay, now, and these two different value of x which give the same value of y, the function. And at last, you have to prove that the x1 and x2 actually is the same value. It's the same value. So if these two is the same value, means that we say that the function to be one-to-one function. All right. So then graphical line, for the graphical approach is we talk about horizontal line test. Horizontal line test, right? Horizontal line test, which I will tell you later. All right. So now in this question, I'm going to do two approach for you, algebraic and graphical approach. Okay, let's look at this. So fx1 equals to fx2 means that we assume that x1 is supposed not to be the same as x2, but these two values produce a same value of y. All right. So then you have 2x. You substitute the x1 into this function, and you have 2x2 minus 1. Right. So then you're solving. So 2x1 negative 1 plus 1, both sides you plus 1, then you have 2x1 equals 2x2, then both sides you divide by 2, then finally you found out that x1 is x2. This one means that for a same value of x, there is only one value of x, then cause the function to have the same value of y, giving the same value of x. So this one means that since fx1 equals to fx2, imply that x1 equals to x2, implies that x1 equals to tell you that x1 equals to x2, therefore fx is a one-to-one function. Right, it's a one-to-one function. So then we say that the inverse, therefore f inverse exists. So means that if the test is already tell you that if this is a one-to-one function, definitely the inverse of the function exists. All right, very simple. So as long as you're getting the result of x1 equals to x2, then the inverse function exists. So this is algebraic test. All right. So let's say we go to graphical test. Graphical test means we're using graph. Okay, we're using graphical test. So we have to sketch the graph for 2x minus 1. So, okay, I'm not going to teach you how to sketch the graph in this video. If you don't know how to sketch the graph, you have to refer to the video that I have discussed about sketching the graph. Okay, so now, okay, you have x, y, 0. So the graph for this one, 2x minus 1, it will be like this. All right, they will intercept at -1, 2x minus 1. So this will be the graph for y equals to 2x minus 1. So if you observe that horizontal line test here refer to, I draw a line, a straight line, this straight line, right? I name it to be y equals to k, and k can be any value. Any value means that the line can be anywhere horizontally. As long as this line, if you move the line, they will only intersect the graph at most one point. If you can intersect the graph at most one point, only one point, then we said that this graph of function is a one-to-one function. So it can do some explanation. Since the line y equals to k, where k is any value, intersect the graph of fx at most. At most means this line everywhere, it may not be intersect the graph, but if they intersect the graph also, 1 point. So they won't intersect more than 2 points. Alright, if this graph moving, they only intersect at most 1 point, means paling banyak pun 1 point. So means that at most 1 point. This one means that fx is a one-to-one function. Alright, at most. Therefore f inverse exists, or we say inverse of f exists. Okay, as simple as that. So this is for linear is a one-to-one. So I'm going to explain. You see, for the same value of x, this is the meaning here. So without the graph, this is actually explaining the graph here. So for the same value of x, for the same value of y, this one fx1, fx2 only have one value here. fx1 equals to fx2. So it means that only one value of y is the output of one value of x here. Okay, only one value of x is giving this value of y. There are no other value of x that can give this value of y. That's why you said we have unique, means that x1 must be x2. Alright, so the fx1 must be fx2, the same value of y giving the only one value of x. Alright, so these two approach you have to understand. First, the algebraic test without the graph, and the graphical test with the graph. Alright, so I'm going to discuss for more examples. Okay, let's look at this function. This is the second question for this video. So how to determine whether this function is a one-to-one function or not. And if this function is a one-to-one function, definitely the function has an inverse function. Alright, means you can find the inverse of this function if this function is a one-to-one function. So the first test that I'm going to use will be algebraic test. Algebraic test. So algebraic test talk about fx1 equals to fx2, right? Fx1 equals to fx2. So you follow, you substitute into this function. You have 4 minus x1 equals to square root of 4 minus x2, right? So then to omit the square root, you squaring both sides, right? You squaring both sides. So you have 4 minus x1 equals to 4 minus x2. So then x1 is a negative x2, 4 minus 4, 0. Divide by negative, you have x1 equals to x2. Yes, you see, this fx1, since fx1 equals to fx2, since this 2 is the result is implies that x1 equals to x2. So therefore fx, therefore fx is a one-to-one function. Is a one-to-one function. If this is a one-to-one function, of course, the inverse of f exists, right? The inverse of f exists. So very simple. As long as the algebraic test give you x1 equals to x2, then the inverse of f exists. So it's the same thing also. Now this is the graph for square root of 4 minus x. So very simple, horizontal line. You just draw a horizontal line. Of course, you don't draw here, right? You draw here, okay? So you draw onto the graph. So you draw to this graph. You see, if this line is moving, if this line is go above anywhere, it's going anywhere. So up and down, they only intercept the graph at most one point, only at one point. Okay, you can check, right? You can draw anywhere. You will only intersect at one point. So this graph I name as y equals to k. So the explanation will be still the same. So since the line y equals to k intersects the graph fx at most, we use the word at most 1 point. Why? Because if the line is drawing here, it won't intersect a point. There are no points intersect. So if you move also, they intersect at most 1 point, right? So at most one point. Therefore, copy this. It's the same sentence here. Therefore, fx is a one-to-one function, and the inverse of f exists. All right. So very simple.